Hello, and welcome to this ANSYS space claim tutorial on thickening an STL or OBJ mesh. I already have the files open here, but if you don't, you want to go to File, Open, browse to the folder where you downloaded it, and just make sure to change the file filter from space claim files to either all files or STL, and then you'll see the two files we're going to work on today, starting with the STL Thicken STL file. So here, if we take a look at the STL that we have, if we zoom in on it, we can see that it has no thickness to it. It's actually just the top faces on a part. This could be from another CAD system, a surface modeling tool, or even reverse engineered off of a scan. A lot of times models that are reverse engineered, when they're a constant thickness, only one side is reverse engineered, and then the model is thickened from there. You'll notice in the tree we have the icon representing an open surface body. And if I were to go to my Facets tab and do a quick check mesh on this, again, it'll confirm that the mesh is not watertight, and notice that we have no other problems in this model. Now in this Facets tab is a tool called Thicken, and you'll notice that after you turn it on, you have the option to choose from thickening it inward or outward. Now, if I go ahead and zoom in here, you'll see that on one side of the part, we have these grayish blue faces, and on the other side, we have these pink faces. The pink faces are the inside, and the bluish gray are the outside. So typically, we're going to want to thicken inside, so we'll leave that set there. Notice you also have a thickness you can change. I'm just going to leave this at the default. And also, sometimes self-intersections are introduced as a result of thickening a part. So here you have the option to fix those self-intersections instead of having to run the intersections tool afterwards. Now I'm going to zoom in on here as I click on the part to thicken. And once I click on the part, the thickening process starts. You'll see this status bar come up, showing you how far into the process it is, what it's doing in each step. It's going to thicken the STL in the direction we specified to the specified thickness. And because I have this fix intersections option on, it'll go ahead and fix those intersections. Now I hit the S key to go back to select, or you could always hit escape to exit out of thicken. And here we can see this nice thickened model. So many models are this easy to thicken. Just turn on the tool, set your dimensions and your parameters and options, and then you click the mesh to thicken and you're ready to 3D print. But let's go ahead and open up the other file, the STL Thicken Repair. Here we have something that is definitely from a scan. You can see there's some deformation on the part that was scanned. There's also the table underneath that part that was scanned, and you'll even see out in some space some other pieces that got included in that scan. Now, just like anything else, the first thing I would try is to turn on the Thicken tool, set whatever parameters I want, and click on the mesh. And in this case, not sure if you heard it, but there was a ding and it was not able to thicken that. If we zoom in, we'll see that this is not thickened. I'm going to escape out of the thickening tool and we can see no thickening happened here. Now, there's a few things to observe with this model. First of all, we do have separate bodies, separate meshes that are not connected to each other. However, in the tree, notice it's one mesh object. Now that's actually okay, but let's do a check mesh to see what is wrong with this part. So multiple pieces, we knew that already. It's not watertight, we knew that already as well. And here we have two issues, over-connected and non-manifold vertex. If I click on the non-manifold vertex, you'll see it highlights two areas over here. And if I go ahead and click on over-connected mesh, we also see it in the same area. And I'm going to zoom in on this area here. And what we can see is it appears there's a triangle here that really doesn't belong there. And if I rotate to the bottom, we see that triangle there. Now I'm going to escape out of the check mesh tool to clear my selection. On the top here, we've got these triangles. And on the bottom, we have two extra triangles here that really are not necessary in this mesh. That's why they're called over-connected. So what I'm going to do is I'm going to right-click and cut them, or I could even just hit delete on my keyboard. I'm going to go ahead and find the other one here. Here we have the same problem. We have this extra triangle on the bottom, and I'm going to go ahead and just press delete on my keyboard. Now we're going to go back to a home view here. spin the model back around. So we've cleaned up the over-connected error. And if we do a check mesh one more time, we'll see that over-connected is no longer there. It's just multiple pieces not watertight and a non-manifold vertex. But I can go ahead and turn on my thicken tool, choose the parameters I want, and now I'm able to thicken this. So what we've experienced is that you can thicken multiple bodies that are not connected at the same time. It doesn't matter if there's a non-manifold vertex, but if it is over-connected, then you will have to remove those extra facets. In this case, there were just two, so it was easy to delete them. But in another tutorial, we'll show that the separate tool has an option to separate over-connected bodies as well. Thank you for watching and have a great day.